It's a bit of a mix-up, this homework task, so let's just dive straight in. So binary addition, just remember that when we are adding numbers together, that we get carryover. So 1 plus 1 is 2, but obviously we write the 1 below the line as carryover. We get 1 plus 0 plus 1, which is going to give us 2 again, with the 1 carrying over. And we get 1 plus 1, which is going to give us the carryover to give us 1, 0, 0, 0, which equals 8. Hopefully you can look at these previous numbers, see that that was 7 and that was 1, and that allows us to double check your answer's correct. So overflow didn't occur there, but just remember the highest number we can write is 15 with a nibble, and the range goes from 0 to 15. So overflow occurs if you to try and store a number that's out with that range. So logical shifts and arithmetic shifts in the wrong order. So if we have a nibble again, which equals the number 8 that we just worked with, a logical shift first, so let's do a logical shift to the right, which is going to divide by 2, should give us a result 4. So if we write down what 4 is and just cheat first of all, 0, 0, 1, 0 is the result we're looking for. And remember that with a logical shift, we shift in a 0 to the front, so we move 0 in. All of the bits move one place to the right. Be careful you don't make silly mistakes. And moving 0 in to this side again. And hopefully you can see that those both give us the same answer. Now a logical shift left applies the same principle. It shifts in a 0 and to a specific side depending which way it's moving, so hopefully you can work out the correct answer from that. The arithmetic shift, however, is slightly different. So let's start off with this number and assume that it's 2's complement, so we'll have to invert it, and we have to add 1, which will give us this, which hopefully you can see is negative 8. So let's perform the arithmetic shift right on that, so we know we need to end up with So the answer we're looking for after performing the arithmetic shift right would be negative 4, because again it divides by 2. So remember the arithmetic shift this time, it retains the most significant bit, so just copy that down. Then the same principle applies again. We shift all of the bits one place to the right. We can just discard this one, leaving us with this as our seemingly final answer. So if we do the usual principle, we invert all the bits and we add 1. Hopefully know that that's 4. It's obviously negative 4 because we inverted and added 1. So as long as you stick to the rules, and for arithmetic shifts you retain the most significant bit. Arithmetic and logical shifts are very straightforward. The last one is graphics calculation, so I'll just give you the kind of rule for doing it, the actual formula. You want to take the length times the resolution multiplied by the height times the resolution times the colour depth in bits. Now the most that's ever going to be for us is 24, so don't be timesing it by 65,536. Now if it tells you the number of pixels, for example the length in pixels, then we can skip this full first step and just do the height times the length times by the colour depth. So just be careful and plug all your units in and practice those. And again, if you need help with those, you really need to come and speak to me, and it's not acceptable at this stage of year 10 to not get these correct. So again, I'm looking for people getting 100% on every question in this and achieving some house points.